Welcome to the UGC EPG Pathshala lecture series in computer science. In this series of lectures, we have been looking at the subject software engineering. For today's session, I will be talking more about software maintenance. Some of the learning objectives of this particular session includes, initially we may have to study on why maintenance is considered as an issue and what is the importance of maintenance given in terms of the overall budget. And further we will try studying on what is re-engineering, reverse engineering, forward engineering and some of the limitations of these engineering principles. Finally, how we come across this maintainability and maintenance. To initially talk about software maintenance, this software maintenance is accepted as a part of software development life cycle. SDLC stands for software development life cycle. This maintenance is widely been accepted as a part of software development life cycle. It stands for all modifications and updations done after the delivery of the software product. So, as you might recall, software development life cycle deals with analysis, design, coding and testing, but as a next phase to the testing, we roll out to the customer as operation and maintenance. So, maintenance plays a vital role during the software development life cycle also. So, there are number of reasons why modifications are required. Some of them I have very briefly given, say for example, in terms of market conditions. If you look at the market conditions precisely, there can be a change of tax, there will be a change of government policies. So, because of which we may have to adopt all the necessary activities to the software. So, it requires maintenance. Not only that, client requirements. So, client requirements is supposed to be the second point, but then after having rolled it out to the clients with the varying set of requirements, client may ask the developers again to reinitiate on the software or to work on the advancement of the software. So, that may also be possible. So, client requirements might also get changed as and when the new software is getting updated. The third point is about host modifications, where we consider the hardware, we consider the platform. In case of hardware and the platform getting upgraded, there needs to be appropriate modifications that need to be done on the software. And organization change. So, in case there is a new adoption of a company, that can also be a part of organization change, or the company has changed its policies, or the company might have laid off some staff members and new staff members would have also been recruited. In that specific juncture, the person who maintains the software need to be trained. So, any new software that need to be updated because of the change of organization change also need to be initiated here. So, for these reasons that we have discussed above, we will try defining what software maintenance initially is. According to the IEEE standard for software maintenance, which is IEEE 1219, software maintenance is defined as the process of modifying a software system or component after delivery to correct faults. So, the major objective with which we start the software maintenance is to correct the faults after delivery, to improve the performance. In order to provide high quality software, the objective that we have been mentioning from the beginning of the software engineering course is to define or give or roll out a product or a software which is highly qualitative enough. So, to improvise on the performance, we may have to increase or we may have to do a maintenance or other attributes or adapt to the changed environment. That those are the changed environments are nothing but the organization change which I was mentioning before. If you look at the entire phase of software maintenance, As we have seen, initial classes where requirements played 40% of the role, design played 30% of the role, and 40% of the role is another 30% of the role is done by testing. But now maintenance plays a vital role here. So, it is almost like 67% of the time we dedicate to maintenance, rather requirements, design, implementation and testing are given quite lower importance, because software once having developed, this needs to be maintained for a longer period enough. Say for example, a software that is developed and still on conditions working for more than 10 to 15 years, now that the entire process need to be reinitiated or it is to be maintained. So, we spend mostly about 67% towards maintenance time rather than the other components like requirements, designing, implementing and testing. This particular slide indicates or gives you an overall intention of how maintenance has changed over a period. So, if you consider early stages during 95s, maintenance was given lesser importance, whereas the hardware was given more importance, and development of software and implementation of the software simultaneously have been given more importance in terms of cost. But as time has driven by, during the year 2000, people started realizing that it is not the simple SDLC phases of analysis, design and coding testing alone is important, rather once having delivered it for the operation and maintenance, this maintenance plays a more vital role when compared to the other requirements collection phase. So, maintenance gained its importance in the early 2000, and today if you look at cost initiated or the budget allocated for the overall project is more towards maintenance rather than for hardware, because all these hardware have been established and people try rolling out the change of platforms alone. But then development cost, software cost and the maintenance cost alone has increased to a voluminous amount. Just by looking at that and to the previous definition of software maintenance, now that it is, here comes another definition of software maintenance. It is as per the standard of IEEE 12207 standard. This defines software maintenance as a modification to code. So, as per 12207 definition of IEEE, an unstructured code, or people do not prefer a structured programming, because of which there could be a large gap of maintenance that could happen. So, we wanted to have a modification to the code and associated documentation due to a problem or the need for improvement. So, any specific problem that has encountered, or there need to be appropriate measure for fault correction, or a system which needs an improvement, or a product or a software which needs improvement in its own state, is what we try to do during software maintenance. So, this is another definition of software maintenance, which gives us concentration more on the modification to the code, documentation and fault. Not only that, anything which seeks more on the improvement. Because we have looked at more of the modification, so I wish to talk more about modification here. We will look at the nature of maintenance in terms of modification. What kind of modification will be majorly sought during the phase of maintenance? So, modification maintenance requests are logged and tracked. So, any modification that is being done are logged, a log file of that is being maintained and it is also been tracked. So, the impact of proposed changes are primarily determined, code and other software artifacts are modified, testing is also being conducted for the modified code, and a new version of the software product is released. So, if you look at all the 4 initial things that we have been pointing, instead of analyzing on the existing code or the documentation of SRS, whatever modification that we tend to do, we keep a log of those files and we try to track it. So, any changes and the impact of the proposed changes, we try to determine those changes. Not only that, we also look after the code and the artifacts associated with the software. Not only that, we again do the same testing. So, this initiates in the creation of a newer version of a software. So, maintainers can learn from the developers' knowledge of software. So, there will be a set of people who are assigned as software maintenance engineers, who will be associated with the developer, but the knowledge and skill set as acquired by the developer will also be caught by the maintainers. Further, we will try understanding what is the necessity and need for maintenance. Maintenance must be performed in order to correct faults. This was defined earlier as I have defined in my software definition, IEEE standards of software definition. So, initially any maintenance activity is to be done to basically correct faults. Not only that, in case if the design is not able to accommodate any changes, so there should be maintenance. So, any improvement that need to be done to the design, we require maintenance. Not only that, a higher version of the software need to be developed, or a newer platform in which I wanted to change the entire software, that means implementation enhancements, we need maintenance. Interface with other systems, we try integrating with other systems which requires maintenance. Adapt programs so that different hardware, software, system features and telecommunications facilities can also be used. It is needless to say that this software has to adopt all the features that the legacy software had. So, we may have to migrate the newer version of the software, either the legacy software to the newer version of the software, or we may have to do a re-engineering to check all the earlier existing features that were available in the existing software have been taken for consideration into the newer versions of software. And if at all versions have been considered, then we try retiring on the software. So, a new enhancement can be particularly made. After studying on the importance of or the need for maintenance, now as I have already told, software maintenance engineers, what are their roles, or what does this person software maintenance engineer do? So, maintains control over the software's day to day functions. So, any operations that has been carried out, see in a large scale, if you look at many automotive systems which are basically handled using robotics or handled by softwares, it requires complete of maintenance. So, any day to day functions that has been done, it requires maintenance control. This maintenance control over software modification is very important, and we need to look at the corrective measures that we may have to take on the functions that were existing, that is perfecting the existing functions. That means, we are correcting the functionality as provided by the software, we use it in the software. Preventing software performance from degrading to unacceptable levels. So, any software as time goes by, the performance of the software need not or should not degrade. In that juncture, we have to prevent software performance from degrading to unacceptable levels. As we have seen earlier, what would be the cost impact for the maintenance? So, majority of maintenance cost. Maintenance consumes a major share of software lifecycle financial resources. That is, from the figure we have been made clear that 7% of the time we dedicate ourselves to the maintenance of the software for large industrial system applications or industrial based systems. So, major share of the software life cycle is spent towards maintenance. But if you look at studies and surveys, it has shown that over 80% of the maintenance effort is used for non-corrective operations. We do not correct, rather to maintain on the high quality, we may have to correct on the systems. So, any faults that has happened, we need to take a corrective measures, and more than 80% of our maintenance efforts is used for non-corrective actions. So, the quality of the software design, construction, documentation and testing is getting affected because of the software maintenance cost. If you look at the evolution of the software, as per the study which has been carried out by Lehman, software maintenance and evolution for over 20 years leading to Lehman's law. That is, as time goes by, there seems to be an increase in the complexity of the software. That is, as a program is getting evolved, its complexity increases unless work is done to maintain or reduce it. So, we do not tend to maintain the software, as and when time permits, the software complexity invariantly increases. So, because of this study on the legacy softwares and the need and the importance of maintenance, there seems to be different categories of maintenance that has been adopted to maintain the same performance or the high quality and performance of the software. If you look at the categories of maintenance, we have 4 basic categories. One is corrective maintenance, adaptive maintenance, perfective maintenance and preventive maintenance. So, if you look at the preliminary of the maintenance, where it ensures the high quality software, which is corrective maintenance, where reactive modification, that means after having rolled out, after having delivered the product, we do a modification of a software product performed after delivery to correct the discovered problems, to correct the faults that has happened after delivery. We say those as a corrective maintenance. Same is not the case with adaptive maintenance, where in case of adaptive maintenance, modification of the software product performed after delivery to keep the software product usable. So, we see to that it is the software that we have already got is still being usable in a changed or changing environment. Either it could be a changed environment or could be a changing environment, we see to that the product still works fine. So, that becomes adaptive maintenance, wherever the platform getting changed, wherever the hardware and the software requirements getting changed. So, we have to see to that the software adapts to those changes and we make the software to work on all comfortable platforms. The third type of or the third category of maintenance is supposed to be the perfective maintenance, where modification of the software product after delivery to improve performance or maintainability. Any software that we have created need to be maintainable. We will look at what this maintainability means. So, any software that we have actually created need to be maintainable, and not only that, the performance of the software need to gradually increase. So, there should be an improvement in the performance rather than degradation of the performance. So, perfective maintenance looks after improvement of performance, not only that, and it looks after perfect maintainability. And the last category of maintenance is supposed to be preventive maintenance, where the modification of software product after delivery to detect and correct latent faults. That means anything that has happened or anything that has been predicted that it would create a problem during the execution, or anything that has been detected to be as a fault, a corrective action has been taken on the product before they become effective faults. So, anything that has been predicted, there need to be a preventive measure which has been put forth for those preventive maintenance softwares. So, after having looked at these 4 categories of maintenance, what is the impact of these categories of maintenance in terms of the development of software? Looking at the key to maintenance in the development, in order to look at high performance and high quality software, there need to be less corrective maintenance. In case of high quality software, we can ensure and say that there should be less corrective maintenance. And if at all we are looking at anticipating changes, any changes that need to be done, and in anticipation we are trying to correct those parts of the code or those design or those requirements, we call that to have less adaptive and perfective maintenance. And in case of better tuning to the user needs, anything that needs to be adopted as per the requirements of the user without any major change in the hardware or software, then it becomes less perfective maintenance. And anything where we need to change on the simple code aspects, say less impact on the code, we say it as less maintenance. So, between these categories of maintenance, we will look at the distribution of maintenance activity. Many a times, in order to have a better performance, that means to provide an appropriate quality or a better performance, we need to do a perfective maintenance rather than corrective, preventive maintenance and so. So, this perfective maintenance initiates that or ensures that the system will have high quality configuration, whereas the percentage of work carried out in the maintenance phase for correction of faults will be only 21%, and preventive maintenance will be the least component, which has only 4%, and adaptive maintenance will be 25%. So, almost like 50% of the time we tend to do a perfectionist job, so as to ensure the increase in performance and high quality software. And most of the people have a very limited understanding on the software maintenance. They consider software maintenance as a post activity that has been done to a software, so why to invest more on the software maintenance. So, we will quickly try to understand how maintenance engineer plays a vital role to have the time and cost as a major impact. So, we will try quickly understanding on the maintainers who make changes or corrections to the software that they did not write. 40 to 60% of the maintenance effort is devoted to understanding the software. So, if you go back and look at the software development life cycle phases, the initial discussions would have told you, if the person who has taken the software for him to develop, if he has not understood the requirements properly, then that software may not land successfully, or it may not be a qualitative software. So, same stands good here. More than 40 to 60% of the maintenance effort is devoted to still understanding of the software. So, comprehension in this particular case is too difficult in the absence of documentation. So, now that we are going to do a re-engineering on the entire software that we have developed, in that specific juncture, if we have not maintained appropriate documentation from the beginning, then comprehension becomes difficult. And when the original developers are unavailable, in case the original developers relating to the software are available and the person who has developed this particular software now getting involved into some other software, and it may be the time that he might have forgotten what he has developed. So, appropriate documentation helps us to bridge the gap between what has been developed with what as an intention the developer has developed this software. So, understanding on the software plays a vital role at the time of requirement studying. Now, the same understanding plays a vital role at the time of maintenance also. So, how have we shifted the type of maintenance over a period of time? If you look at the introductory stage, where emphasis was given more on the user support, whereas during the development or growth phase, emphasis have been given to correcting the faults. At the delivery stages, that is at the maturity phase, emphasis is given for enhancement, whereas at the decline phase, that happens quite normally, or that happens quite very at a meager amount, emphasis is given more on the technology changes. So, something would have been developed using, say for example, HTML, now that people wishes to shift it to PHP. So, as and when the platform is getting changed, how to adopt to the changing requirements as given by the user in change of or in accordance with the change of platform. So, we may have to look at all these into mind at different phases of the software maintenance cycle. So, we start with the introductory phase where we gave importance to the user support. During the development or growth phase, we gave importance to the corrective faults. During the maturity phase, we gave importance to the enhancement, whereas at the decline phase, now it is the right time to change the technology. So, technological changes need to be taken care of. If you look at the major causes of maintenance problems, it is not really with the structured programming of the document, it is to the unstructured programming that a developer has taken into control. So, any unstructured code that has been developed could be a major cause for maintenance problem, and a person who has got a limited domain knowledge, insufficient domain knowledge would actually be a problem during the software maintenance. And not only that, if it has got limited documentation or no documentation or insufficient documentation, this might also fetch us a problem during the software maintenance. So, there may be situations where we may not be able to produce change of requirements as defined by the clients in case of any one of these problems. So, what we tend to do is we do an impact analysis. How about when it comes to impact analysis, if we do not understand or if we do not create awareness to the software maintenance. So, the objectives of impact analysis are, we tend to determine the scope of the change in order to plan and implement the work. So, what is the scope with which we are supposed to work on the software? We tend to analyze or we tend to study on those instead, and development of accurate estimates of resources needed to perform the work, analysis of cost benefits of the requested changes, communication to others of the complexity of a given change. So, anything which need to be communicated to others in terms of complexity for a given change, we may have to study on that also. In short, in this particular session, we have started discussing about software maintenance, and we have further said this maintenance is also being a part of software development life cycle, and it is after the delivery of the product. So, what we have done is, initially we have tried discussing about the importance of maintenance at various stages, starting from organization change, it could be on the client requirements, it could be on the hardware software platform changes, and it could be on the change impact. Further, we started defining about the maintenance as correcting the faults. IEEE definitions of software maintenance we have given, and we have also looked at the nature of maintenance activities that has been carried out, and we have stressed on the importance of or need for doing the maintenance activity. Not only that, in order to maintain the high quality software, we need to do a perfective maintenance. So, we started defining the various categories of maintenance and maintain control over software's day-to-day function in case of industry automotive applications, where we need to have a maintenance which should concentrate more than 40 to 80% of the times. So, maintenance consumes a major share of software life cycle. If you recall the image that I have projected, it does to 67% of the time we concentrate on software maintenance, software life cycle, financial resources. Thank you.